Hello, my name is Chris Kissler, and this is my presentation for my Capstone project for CSU Channel Islands. My project is called Lockstep in a Nutshell, an interactive exploration of fighting game netcode. So what is netcode? Netcode is a broad term that refers to the systems that keep multiple users' games synchronized. So all video games are a series of frames that are affected by the user's input in some logical way. In this example, you use 4 keys to control a little stick figure that's able to fight this other stick figure. It's a simple fighting game. So Lockstep netcode specifically has a few extra requirements of the video game. The video game must effectively be a deterministic function that outputs a game state after being fed a previous game state and some new controller input. So the deterministic nature of games is what allows Lockstep to work. And this is an example of something else determinism allows to work, which is simple recordings of gameplay. So if I can play here just normally, but if I hit record input and do some gaming and then hit stop recording, I can then hit playback recording, and you'll notice the exact same sequence of events occurs. And all that's being recorded are inputs and the frames that they occur on. So no game state information has to be stored because the game is deterministic. As long as I start in the same place at the beginning of the game and then give it the same inputs the entire time, I will always get the same output at the end because the game is a deterministic function. All that Lockstep is really saying is that if you have 2 users on separate machines running the same deterministic game and you give them both the same sequences of inputs, that they'll both see the same game. And that can be used for multiplayer. So you both send each other inputs, and then you both have the same sequence of both your inputs and their inputs, and then you'll have the same 2-player game play out on your screen. So is that sufficient, just that concept alone? Well, this demonstration here hopefully shows that it's not. So you can already see as I walk here, something's wrong. And if I jump, it becomes pretty apparent. Time is like dilating back and forth. Sometimes you're going normal speed, sometimes you're going really slow. And so the reason that that's happening is that when the latency between the 2 users increases to greater than a single frame of gameplay in time, suddenly your game has to wait that amount of network latency for the inputs to arrive that it needs to proceed to the next frame and still be sure that it's synchronized with the other user. So if your latency is higher than the amount of time that a frame is supposed to take, you're going to end up having the game freeze to wait for the other inputs to show up. And this is what that looks like. It looks like slowdown. The input response time becomes dependent on the latency, and it feels really bad to play. So what is the solution to that? The solution to that is something that most fighting games that are popular now use, and that's delay-based netcode. The idea here is that by introducing input delay in the form of a queue of inputs, you can have an old input ready to be paired with an input that the remote user sent off a short amount of time in the past. So by delaying your inputs locally and rendering frames based on old input, you're able to be fairly confident that you'll have inputs ready to be paired when remote input shows up. The downside of that is, as you can see here, this is the most recent frame, the most recent input, and this is an input from 8 frames ago. And this is actually the one that we're using to generate this game state that we're seeing. And so that means that you're actually feeling that input lag. It feels more sluggish. When you press it, it doesn't react instantly because you're literally having to wait 8 frames to see the input that you just put in. But the upside is your game no longer chugs when the latency surpasses a single frame, which is good because that's only like 16 milliseconds or 32-ish milliseconds round trip time. And yeah. So this is largely the industry standard. Some games don't use it. Some games use a more advanced form of Lockstep called rollback. And that's a predictive form of Lockstep where you still have this going on under the hood, but the game extrapolates several states forward using your inputs that it knows and predicted inputs for the remote user, such that what you see is a more responsive game, as long as you don't well, it's called rollback for a reason. Sometimes something else actually happened that didn't show up in the prediction, and then things have to roll back, and you don't get to do whatever you did for those 8 frames. And there's all sorts of small little hiccups that can happen with rollback, but overall it's largely a more robust system. But that's not gone into in this article. In the future, it may be updated, and my social media here is listed so that if it is updated, you can be notified. Anyway, thank you for listening to this presentation, and have a good one.